In this video, we're going to talk about Hess's law. So Hess's law tells us that if we have a reaction that is the sum of two or more reactions, delta H for that reaction is the same as the sum of the delta H reactions for the two reactions that we had to add together. So for example, if we look at reaction 3 here, if we're trying to get reaction 3 by adding reactions 1 and 2 together. So if we look at reaction 1, we have carbon monoxide as a gas on the product side of the first reaction, and we have carbon monoxide as a gas as a reactant on the reactant side of the equation. If we have a substance that appears in the same form, in this case we have carbon monoxide as a gas on both sides. And we also, if we look carefully, we have 3H2 as a gas, and we have 3H2 as a gas on the reactant side of the second equation. So if we cancel those out, that leaves us with CH4, 2 H2s, one from reaction 1 and one from reaction 2 on the reactant side, and that leaves us with 4H2 and with carbon dioxide on the product side. So if we add together delta H from reaction 1 and delta H from reaction 2, we get delta H from reaction 3. So let's look at a couple more things we have to take into account. What if we have a reaction, but in our reaction that we're trying to get, something is on the opposite side? Well, we can flip our reaction, but if we reverse the reaction, we also have to reverse the sign of delta H. So if we flip this reaction here, so that the products become the reactants and the reactants become the products, all we do is flip the sign of delta H. Sometimes we need more of a reactant or product than we have to start with. And the way that we fix that problem is multiplying the reaction by a coefficient. But if we multiply the reaction by a coefficient, we have to also multiply delta H by that same coefficient. So for example, the reaction shown down here at the bottom is 3 times the reaction shown here. So this reaction here is 3 times this reaction, which means that we also have to multiply delta H by 3. So let's take a look at an example here. We're trying to get the reaction C2H4 as a gas plus H2 as a gas yields C2H6 as a gas. So let's look through these reactions. We're looking for C2H4, and if we look down through the 3 reactions that we have, we find C2H4 on the reactant side of the second equation. Now, we also need H2 as a gas on the reactant side. So if we look through our 3 equations here, we find H2 as a gas on the reactant side. So that takes care of those two. And then on the product side, we want C2H6 as a gas. If we look through our 3 reactions here, we have C2H6 as a gas, but it's on the product side of it's on the reactant side of the equation, and we want it on the product side. So what we can do is flip this equation. And when we flip it, we will also have to flip delta H. So I'm going to copy our reactions down here at the bottom. So we have H2 as a gas plus 1/2 of O2 yields H2O as a liquid. And delta H for that reaction is negative 285.8 kilojoules. Then our second reaction, we have C2H4 as a gas plus 3O2 as a gas yields 2H2O plus 2CO2. And delta H for that reaction is 1,411 kilojoules. And then our last reaction, we have to flip this. So we have 3H2O plus 2CO2 gives us C2H6 as a gas plus 7/2 O2 as a gas. Now because we flipped this reaction, delta H was negative, it now becomes positive. So then we need to go through and cancel out everything that shows up on both sides of the equation. So we can start with, we have 2 carbon dioxide and we have 2 carbon dioxide. So that one's nice because it matches up perfectly. There's 2 carbon dioxide on the product side, there's 2 carbon dioxide on the reactant side. Now there's a couple more things we can cancel out, but we might have to look a little harder to find them. So we have H2O here on the product side. On the product side of these two equations, but on the reactant side of this equation. But if we add this together, 1 H2O plus 2 H2Os is 3 H2Os, and we have 3 H2Os on the reactant side of this other equation. So we can cancel those out. These 3 will cancel out with this 3. And we can also do the same thing if we look at the O2s. We have 1/2 O2 plus 3 O2s here. So 3 plus 1/2 is 3.5. And we have 7/2 O2 in the bottom of this last equation. Well, 7 divided by 2 comes out to 3.5. So we can cancel out the 3.5 O2s here with 7/2 O2 there. So, now that we've canceled everything out, we're left with C2H4 as a gas plus H2 as a gas yields C2H6 as a gas. So then we can add up our delta H values for these 3 reactions. So put into your calculator negative 285.8 plus negative 1,411 plus 1,560. And you should come up with negative 136.8 kilojoules for your value of delta H. Okay, let's look at one more example here. We want to get the reaction N2 plus 2O2 yields 2NO2. And we're given some equations down here. So let's start with N2. If we look through these 3 equations, we have N2 as a reactant in the first equation. If we're looking for O2, we have O2 in the third equation, but it's on the product side. So we're going to need to flip this equation, and we have one more problem here. Because this reaction only shows 1/2 O2, but we need 2 O2s. So what we can do is we figure out what we multiply 1/2 by to get 2. And we would multiply that by 4, because half of 4 is 2. So we're going to have to flip this equation and multiply it by 4. Now before we start doing anything, let's go ahead and find 2NO2 and see if we need to do anything. So if we look down through our 3 equations, we have 2NO2 on the product side of the second equation. So N2 and the NO2 are in the right place with the right quantity, but we've got to flip the third equation and multiply it by 4 to get the right quantity of O2 in the right place. So I'm going to go ahead and go to a blank slide and copy these equations over. So we have N2 as a gas plus 3H2 as a gas gives us 2NH3. We have 2NH3 for our second equation. And delta H is 142. In the last equation, we flipped it and we multiplied it by 4. So we have 4H2 So our delta H was originally negative 43.7. We're going to flip that, so it's going to become positive, and then we're also going to multiply it by 4. So we get 174.8 kilojoules. So we can go through and cancel out everything that cancels out. So we have 2NH3 cancels with 2NH3. And let's see, 3 plus 4 is 7, and we have 7 H2s over here. So that cancels out. The 4 H2Os cancel with the 4 H2Os. And all we're left with are the N2, the 2O2, and the 2NO2. So we have N2 as a gas plus 2O2 as a gas yields 2NO2 as a gas. And if we add all the delta H's together, that comes out to negative 82.7 kilojoules. So we will stop here and we will get some more practice with this in class.